part of your bell work, we're looking at expressions, and that's what this whole entire section is about. It's really important that you start learning keywords, which hopefully these are all familiar. We're going to add some more as we go. They wanted you just to write these out algebraically. So added, obviously we know that term. Subtracted, we know divided. Hopefully to this point you have used of in regard to multiplication. Of is typically multiplication. We've talked about reciprocal, and we've also talked about absolute value. And so they just wanted you to take the terminology written out in English and translate it to a mathematical phrase. I always say that I teach a foreign language because math is its own language. It is the universal language. You go anywhere in the world and the language is the same. All right. And so when we think about languages, we think about translating. So if your native language is English, then when you learn a different language, you will translate it. So if you learn Spanish and they say hola, in your brain, you're going to flip that and say hello because you're going to naturally translate that to your native language. And so if your language is native other than English, then when you learned English, you probably did the same thing. So when people grow up, they relate words to items, right? So I have cup, and in my brain, when I hear the word cup, or when I hear the word plate, but in Spanish, if I hear el plato, my brain is going to convert to plate, and then it's going to convert to the image. And so that's kind of what we do with math. We take the language and we convert it to the math symbols, so then we can do something with those math symbols. We're just translating it. And so that's what variables help us do. They help us put a placeholder for something that stands for something, and then they help us take the different language and they convert it to math symbols so that we can then calculate those math equations. All right, and so that's what we're going to be doing here. If you turn to page 46, we have this example where they're coming up with kind of a cost for what it's going to cost them. They have different types of soft drinks, a price per can for the soft drinks. And so you see this per item, per can. Can is what we don't know. And so number of cans we didn't know. So here we said we have 62 cans. So in this case, if we don't know the can, we may assign something to the variable like a C for the can. Here what they did is they said, we know we're going to do 62 cans. Now we want to know what the cost would be, or the total price. So they assigned a P to each of these. And you can see depending on what it was, the price changed. So they said over here it's 62 cans. We just want to know what it costs. Well, it depends. It depends on which one of the drinks you're talking about. And so that's why they're called variables. If you look at the definitions at the bottom of that page, you see the first one is variable. It's a symbol used to represent an element of a given set of numbers. Variables can change. They vary, hence the term variable, all right? And so when you see an X, it represents a set of numbers. It doesn't represent just necessarily one number. It can represent a set of numbers that make that equation true, all right? And so we use the term variable when we do not know what it is. We know it stands for something, but we don't know precisely what it stands for. Constant, however, is just that. It is constant. It does not vary. It is a fixed number. 1, 2, 3, those are constants, all right? And so variables will be represented by usually a letter. Constants are numeric. Those are numbers. So then algebraic expressions can put constants and variables together. You can have numbers, variables, and operation signs in algebraic expressions. And by operation signs, they mean plus, minus, multiply, divide, things like that. So then once you get an algebraic expression, you can evaluate it. So this is a term you need to be familiar with because this will be in your instructions for me sometimes. My instructions will say evaluate the algebraic expression. In order to evaluate, you have to have all numbers, by the way. So very often they'll give you all these variables and they'll tell you what each variable represents. And you need to plug it in and evaluate, which means solve it. Which always, by the way, you have to use order of operations when you solve an algebraic expression. So when you substitute in the values, you're going to solve it based on just number crunching, just order of operations. And so we're going to start doing some expressions, then we're going to start creating our own expressions. And this is going to help us as we get into word problems. We're going to build it a little at a time. so that when you get into a word problem, you see these keywords and then you can translate it to an algebraic equation and then you can solve the equation. So first, let's just talk about a term called domain. So let's look at the top of page 47. Example 1. Evaluate the expression x plus 9 for each member of the domain. So when you see the word domain in math, this is going to stand for the input values. Very often in XY equations, it is the x value. But specifically, it is what you are inputting, domain, what you are inputting into a function. The output of the function is going to be the range. So they have given us the domain. The domain here is a set of numbers, which we should recognize by that little set symbol. And it is -5, 1/2, 2, 3. So they have said x can be one of 4 different things. And I've given you the 4 things that x can be. Now, I want you to tell me what happens when you plug in each one of those. All right? And so what you're going to say is, well, the first one is that x equals -5. Well, what happens when x equals -5? Well, I'm going to plug it in. -5 plus 9. And then I'm going to do the operation, -5 plus 9. That equals 4. So when x is -5, then my output is going to be 4. And they want me to do this for every single one of these. The next one's 1/2. So if they want me to evaluate it at 1/2, I'm going to simply say 1/2 plus 9. That is just 9.5. Or you could write it 19/2, right? And so evaluate just means plug it in and solve. When you plug it in, order of operations. And then when you solve it, you're just going to do your rules that we've been talking about for the last couple of weeks. And so evaluate simply means plug in, do order of operations, and solve. And so they have given me 4 different ones. They want me to evaluate the 4 different ones. So then if they ask me for the range is going to be a set of numbers. So you should have your set notation, and you want to list it in least to greatest. So this is 4. 19/2 or 9.5, 11, 12. So my answers here would be a set of numbers. I don't have one number as my answer. They gave me a set of numbers to put input. I have a set of numbers to output. Set of numbers to output. All right? So they can do it just like this. Evaluate, they give you this expression, and then they give you the 4. If you look at the next example on that same page, they've basically done the same thing, but they've written it out. If C represents the cost of 1 pencil in cents, the algebraic expression 10C, or 10 times C, represents the cost of 10 pencils. That makes sense. So if C is how much 1 pencil costs, then 10 times C is 10 pencils. If the domain of C, or in cents, is 5, 10, and 17 cents, evaluate the expression for each member of the domain. So what they're saying is, okay, I have pencils. They cost C amount of cents. I want 10 of them. So my total cost then is going to be 10C. And now they want to give me the 3 types of pencils that I have. One costs 5 cents, one costs 10 cents, one costs 17 cents. So if I were to plug those in, my range of pencils would say 10 times 5. Well, that would be 50 cents. 10 times 10, that would be 100 cents, also known as $1, right? 10 times 17, that would be 170 cents. $1.70. By the way, if you do not do your symbols, you need to make sure it's all in the same. So if you told me this was dollars, you could say 0.501 and $1.70. If you left it as cents, then you would say 50, 100, and 170. But you kind of need to tell me how you're doing it. Okay. All right, so for the first one, you plugged in a -5 plus 15, a 2 plus 15, a 3 plus 15. You should have gotten 10 17 and 18. And actually, when I give this to you, I would actually want it to look like this. All right. For the next one, you're going to do the same three numbers, but you're going to do it for 3y minus 8, which means order of operation tells you to multiply that 3 and then to subtract the 8. You would have done the same thing for negative 5, 2, and 3. Multiply by 3, subtract 8. Make sure that you are doing your positives and negatives correctly. Negative 5 times 3 is negative 15. Negative 15 minus 8 is negative 23. So make sure you do plus a negative there. All right? Questions on those? So these are just some of the key words that you're going to see. Addition, sum, obviously, that's one that hopefully you've heard. Add, I know you've heard. More or increased, okay? Subtraction, difference, subtract, less, decrease, diminish. Pay attention to less because they can use it two different ways. If it's 5 less than 10 versus less than as in he spent less than $100. So be careful of the word less and make sure you're not doing an inequality, which we will get to later on. Multiplication, product is the primary one. You'll always see times, obviously. You'll also see something like twice the number plus 3 or twice the width minus 2. And that means multiplication. Of is very often multiplication. So 3% of 100 is 0.03 times 100. All right, and so of means multiplication. Doubled is the same thing as twice. Division, quotient. Quotient is the number one you probably learned when you were in elementary school for what you're doing when you do division. Divided by, obviously, half. Half of, that's actually dividing, but you can also think of it as 1/2 times. So 1/2 times or half of something, you're actually dividing by 2 or multiplying by 1/2. Per, you also have to think this is unit. So I'm going to be very careful with per as well because sometimes per can be used with multiplication. If it's a price per pound, technically it is a unit conversion. But if you were trying to figure out the total price, you would actually multiply. So this one can be tricky. So pay attention to this. Sometimes you can mean multiplication when you see that. Average, that is a division. Now remember, when you take average, you have to take the sum first and then divide, but you'll see average is going to lead you towards a division problem as well. All right, so let's look at translating these. The sum. The sum means multiplication of a number. When you see the word a number, that represents a variable because they did not tell you which number. And then and 4. So the sum of a number and 4 is going to be some variable. You may choose which one. I usually do x plus 4. They did n. All right, so the sum of a number and 4, that's x plus n. B, the difference between a number and 5. Well, that is going to be a variable minus 5, subtraction. 1/3 of a number, C. 1/3 times n. You'll notice they wrote this two different ways. 1/3 and then the n beside it, or the n is just on top of the 3. The n is just on top of the 3. All right, so that is the same thing. Think of it as n over 1 and they just multiplied across. 1 times n over 3 times 1, right? And so you can write it either way. They're both the same. All right, let's look at the E. The sum of 3 and 8 times the number. So they want the sum. So anytime they say the sum of, and then they give you a group, think of it as a group. All right, so they're saying the sum of 3 and 8 times the number. Order of operations would group the 8 times the number, which is exactly what this does here. 3 plus 8x. We do not know the number that they're talking about. We just know we're multiplying 8 by it. And we are doing addition with 3. So 3 plus 8x. 3 plus 8x. And order wouldn't matter here either. You could do 8x plus 3 because it's addition. The next one, however, order does matter. 8 less than 3 times the number. So this is the most common mistake that I see when I give this one. All right? 8 less than 3 times the number means that you are subtracting the 8. All right? Which means the 3 times the number comes first. So for this one, you would have, we jumped over one. 3n minus 8. So you would have the 3 times the n minus 8. And this is the one where I said it gets confusing. 8 less than 3 times the number. If you don't know what order it goes in, if I said you have 8 less anything than someone else, you know you're subtracting the 8. Okay? And so this is the one where they flip it. Sometimes people will say 8 minus 3x, and that's incorrect. The 8 is actually what is being subtracted here. So this is the one that confuses people the most. G is the quotient of the difference of a number and 8 and twice the number. Quotient. So we know one of my operations is what? Division. They want the quotient, and when they list quotient, they will list the numerator first, by the way. So the quotient of the difference of a number and 8. That's going to be x minus 8 or n minus 8 or whatever my variable is. And they want that between twice the number. That's my denominator. So if they had said the quotient between 15 and 3, it would be 15 divided by 3. They said the quotient between this group and this group. So they listed the groups in order, numerator, denominator, but you still have to group them that way. So my numerator here is the difference of a number and 8, n minus 8. My denominator here is twice the number, 2n. All right, let's look at the last one. The opposite of the reciprocal of the square of a number. How many words can I put into one? All right, opposite's always going to be negating. All right, so if I said the opposite of 3, you would say negative 3. So this opposite piece is going to give me a negative. All right. The reciprocal, I know I'm going to flip something. The reciprocal of the square of a number. How do I write something squared? Well, I put a little tiny 2 above it with an exponent. They don't know what I did. It's x is my base because they said a number. They want the reciprocal of x squared. How do I write the reciprocal of x squared? I just flip it 1 over, right? So I know that I have the square of a number. That looks like this. They want the reciprocal. That looks like this. They want the opposite. That looks like this. So it's negative 1 over some number squared. Does everybody see how we did that? Just do it a piece at a time. The sum of 3 consecutive integers. All right? First of all, what operation am I doing with sum? I am doing addition. So I know that I'm going to add these up. This is addition. Consecutive integers. Did they give me the integers? No. So I know, let's just say my first integer is 1. Okay? Let's say that's my first one. Sum, I'm going to add it to how many integers? 3, right? So I'm going to take that x and I'm going to add it to some other integer and to some other integer. What does consecutive mean? Consecutive. So if I said 3, you said 4 automatically. What did you do to get there? You added 1. So if I say x, what's my next number? That's multiplying by 2. What did you do from 3 to 4? You didn't multiply by 2. What did you do? You added 1. So how do I go from x to the next one? I'm going to add 1. How do I write that algebraically? How do I write x when I add 1? Yes, everybody see that? So if I had 3 here as my first one, you said my next one was going to be 4. What did you do to get from 3 to 4? Well, you added 1. Correct? What would be the next one after 4? 5. What did you do from 4 to 5? You added another one. But what did you do from 3 to get all the way to 5?
You add 2.
There you go. So what is this last guy right here?
X plus 2.
There you go.
Wow.
That is the sum of 3 consecutive integers. I started with one I didn't know, but I do know the next one's going to be 1 bigger than that guy. And I do the last one's going to be 2 bigger than that guy. What if I wanted to add a 4th one? It would be x plus 3, and there's your pattern, right? There's your pattern. What if I had said even numbers? So even numbers. I start with x. Let's say I start with 2. How do I get to my consecutive even number? I'm going to add 2 because that would give me 4. So if I wanted to add even numbers, it would look like that. What would my next even number be? Yeah, it's going to be 6, so it's going to be x plus 4. That's right. Does everybody see that? So pay attention to the words that they're saying and think about logically how you would go from one to the next. Even if you have to write down an example. What would odds be?
3, 1, 3,
They are, but how far apart are they?
2.
It would be exactly the same if they had asked for odds, by the way. Because odds are also 2 apart, right? Consecutive odds are 2 apart. 3 to 5, that's 2. 5 to 7, that's 2, right? And so think about what they're asking you. And if you don't know, get an example with a number and say, well, how did I go from here to here? And then fill that in with an X, all right? So I want you to try some of these. Translate all of these into algebraic expressions. If you don't know the number, you are going to put a variable for it. And sometimes they relate to each other, all right? So if you have pennies and nickels, you can say P and N, but then you may have to replace one with whatever it's related to. 5 more than that. Well, that's going to tell you a relationship. So the first one wants the number of pennies if there are 5 more pennies than the number of nickels. So ultimately, we want to set something up that tells us how many pennies we have, all right? You really just needed the right side of this, though. So if I had, let's say, 7 nickels, how many pennies do I have? 12. So you said if I have 7 nickels, then I must have 12 pennies because there are 5 more. What did you do?
7 plus 5.
You said 7 plus 5. Do I know how many nickels there are?
No.
They didn't tell me. So I need to pick a variable for nickels. We'll just say N. So then how do I find how many pennies if I have N nickels? N plus 5. That's what my pennies would look like. It would look like N plus 5, right? The next one is similar. The length of a rectangle. That's what we're actually trying to find. But we want it in terms of the width. It is 10 inches longer than twice the width. Do I know the width? I do not. So I do not know what the width is. What do I need to do to the width, though? I need to do 2 things to it. Twice means 2, multiply by 2. So I need twice this. And I also need something else to do to it. What do I need to do? Yeah, I need to add 10. 10 longer than. And so 2W plus 10. Twice the width. It is 10 inches longer than twice the width. That's what the length will look like. 10 inches longer than twice the width. Let's look at this one. The number of girls in Miss Lyda's class, if there are 3 fewer than twice the number of boys. Do we know how many boys there are? No, but we're doing 2 things to that number of boys. What are we doing? We're doubling it, and we are subtracting 3, right? So even though we don't know how many boys there are, if we were talking about girls, we would take the boys, we'd double it, and we'd subtract 3. And algebraically, it looks like this. 2 times the number of boys minus 3. 3 less than twice the number of boys. That's what the girls would look like. All right? The quotient. Quotient means division. The numerator of this quotient is the sum of a number and 7. We don't know the number, so we need a variable. What is sum? Addition. So my numerator here is an addition between some number and 7. My denominator is twice the number, which is what? Addition, subtraction, multiplication, division. Twice is multiplication. So it's going to look like this. The numerator is n plus 7. The denominator is 2 times n. Same number, we just don't know what it is. The difference. What operation is difference? Subtraction between a number and 12 times that number. We don't know the number. So we're going to say that number minus a multiplication between that number and 12.